Hi, hello everyone. Welcome back to my YouTube channel Sporifii Learn. Today I am here with the video of chemistry first PUC chapter 1, that is some basic concepts of chemistry. Some basic concepts of chemistry. Now let's discuss. First topic is that we should understand what is the definition of chemistry. It is a branch of science that we all can understand, that what it will deal with: composition, structure, properties of matter. Matter in the sense it is divided into three, that is solid, liquid and gas. Those are states, okay? And it is also called the science of atoms and molecule. It is the science of atoms and molecule is included, right? So it is called as science of atoms and molecules. And let's see what are the branches that come under chemistry. Organic chemistry, which you also have, this deals with the study of carbon compounds, especially hydrocarbons and their derivatives. Hydrocarbons means it starts with H and all, and it deals with the most of the structure, and most of the next upcoming chapters in your lists will be hydrocarbon. If it is, it will be connected to carbon, and this will be connected to some hydrogen, again it can be connected to carbon. That all we'll discuss in the next upcoming videos. And next branch is inorganic chemistry. Inorganic chemistry is nothing but it is the study of compounds. Here it is carbon compounds, okay? Here it is only compounds of all other elements except carbon. Yeah, see, here only you can understand. Here they had mentioned about carbon, here it is except carbon. All the elements will study, okay? And it largely concerns itself with the study of minerals found in earth's crust. What are the minerals that are found on earth's crust is mentioned in inorganic chemistry. And if we see the physical chemistry, which we are studying right now in this chapter, this explanation is fundamental principles. As the name itself suggests, some basic concepts, right? Basic in the sense it is fundamental. Fundamental is nothing but basic, okay? And this deals with the principles governing various chemical phenomena, is the main concern of this branch, okay? It deals with the fundamental principles. It is basically concerned with laws, theories, different branches of chemistry. It deals with most of the times is theory, okay? And next, these are the three types of chemistry we are having in first PUC and both in second PU also. And next comes is in industrial chemistry, that is involved in industrial process. In industry, what are the process that they do for manufacture or something else, that is called as industrial chemistry. And analytical chemistry is the another type, that is qualitative and quantitative, that deals with analytical. Biochemistry means it deals with the bio itself suggests living organism, that is plants and animals. It deals with the biochemistry. Nuclear is the sense it is nuclear reactions such as nuclear fission, fusion, transmutation, and all our studies under this branch. Now let's deeply discuss into this chapter. These are just, you have to know, there is nothing important in this, okay? Now let's see on to the properties of matter and how they are measured. Every substance has unique or characteristic properties, okay? They have unique or characteristic properties. These can be divided into physical and chemical. They are divided into what? Physical and chemical. And next comes is, let's continue with the next concept, that is physical and chemical properties. Physical properties in the sense it is the properties which can be measured or observed without changing the identity or the composition of the substance. Example: color, order, melting point, boiling point, density. See, what is they are trying to say is, they are the one properties which can be measured. It can be measured, okay? And it can be observed also without changing the identity of the composition. Like, see, color, if you have to find, you can measure or you can observe the color, and nothing, the composition of the substance, what the color is, actually the composition will not be changed. Odor in the sense it is smelling. And next is melting point and boiling point and density also. If we come to the chemical properties, they require a chemical change to occur. See, they are the measurement or observation same, but they need a chemical change. This is nothing but it is measured or without changing the identity. Here the chemical change have to happen to occur. This example, burning of magnesium. Mg means magnesium. You should know all the periodic table elements. Mg, magnesium ribbon in air. Okay, this is one example for chemical properties. Okay, now chemical properties are characteristic reaction of different those have acidity, basicity, how much acidic they are, and their pH level to check and all, and are they base or acidic to find out that, and combustibility, etc. Many properties such as you can find out the length, area, volume are quantitative. These are qualitative, and these are quantitative. Okay, and next comes is metric system, that is was based on decimal system. This is based on decimal system. Next is the international system units, that is SI units. We call, no, in physics also it comes that some SI unit of current is ampere, like that. The SI unit is nothing but international system of units. Okay, these are nothing but in French some lay system, international D unites abbreviated as SI. They found out here and was established in 11th General Conference on Weights and Measures. See, that is CGPM from CGPM means Conference General Despoids at measures. The SI system have 7 base units. What are those? Length. These are the quantity that we have to measure. Okay, see, if you have to measure length, see, if you have to find the length of this line, means you say in meter, this is 10 meter or 5 meter or 2 meter, etc. So you measure in meter, and the unit is meter. See, M is the symbol that is used to, that if you take the full form or what is this, you say as meter. Okay, mass means some, you will go for some shops or some anything, you have to buy grocery items, and you go and say give me rice, and you will not say as give me 1 meter rice, you say as give me 1 kg rice or 1 kg dal, something like that you will say. That is mass. Okay, that is you kg means kilogram. Okay, kilogram. And next comes is time means, yeah, you can measure in hour, minute, second, but the SI unit means, as we studied here, according to French lay system international D units abbreviated as SI, according to them we have to measure in seconds. Okay, now you have to say, as if you measure time, you most probably measure in S is the small s. Okay, not capital S, it is small s, and the time is second. Okay, and if you have to measure temperature is, you can measure also in degree Celsius, but Kelvin is the SI unit. Okay, and next is amount of substance, how much quantity of substance you are having in one particular molecule or something. Mole, MOL is the symbol used, and the full form is mole. Okay, and as we said, yeah, see, electric current, A, capital A is there, and ampere is there. And luminous intensity, this is one of the most important. CD, capital C and small d is used to represent this symbol, and we say as candela. Let's see what are the prefixes in SI system. See, there is pico. What are they? There are, see, pico is there. N means nano. This, like this, if we write it as micro, it is. And next is small m means milli. Okay, and centi. Next, C means centi, D means deci, DA means deca, deca means 10 it is. Hecto, H, kilo, K, mega. See, here this and this you need to observe, because here there are capital and small m's. If it is small m, it is milli. What it is? Milli. Okay, if it is capital M, it is mega. You can remember as capital, right? So it is big. Big means what? Mega only, right? So you can remember like that, mega. And next, capital G is giga and T is tera. Okay, now see, let's see what are the prefixes. Means P means pico, nano, micro, M means milli, centi, deci, deca, hecto, kilo, mega, giga and tera. Okay. See, if it is comes to pico means it is 10 power minus 12. This you have to remember. This you have to remember. It is most important concept. It is very important concept. You have to remember. Okay. Pico means it is 10 power minus 12. Okay. And if it is 10 power 12, it is terabytes. Okay. And if it is 10 power minus 9, it is nano. Okay. If it is plus 9 means giga. 10 power minus 6 means micro. Capital 6 means mega. Okay. Minus 3 means milli. 3 means kilo. And minus 2 means centi. And plus 2 means hecto. Minus 1 means deci. And 10 means deca. Okay. These are the very important concepts you need to remember, as this name itself suggests as some basic concepts of chemistry. And next comes is mass and weight. Mass is nothing but of a substance is the amount of matter present in, while weight is, it is something amount of matter, how much. See, as we can say, as I gave example, you can ask as 1 kg rice or 1 kg dal, something like that. What is the amount of matter present in it, that is called as mass. Okay. Weight is nothing but the force exerted by gravity of an object. Okay. Weight is nothing but it is force exerted by gravity of an object. The mass of a substance is constant, whereas weight may vary from one place to another place due to change in gravity. See, in one place the weight may be something around, weight you can say as 1 kg or 0.5 kg, something like that. Due to some gravity, if you took the same weight in another place, it can vary due to gravitational force, and that is weight. But mass cannot change. If you take 1 kg rice in one shop, they will give 1 kg, it will be having the same quantity, and in another shop also, if you go and ask the same, it will be the same. And next is mass of the, it is determined very accurately by using analytical volume and balance. Okay. That is measured in that. Volume means what? It has the units of length cube. Okay. Volume is nothing but length cube, and so volume has meter cube or centimeter cube or dm cube. Okay. A volume contain in liter, not in, is not an SI unit. Liter, see, we say as volume. You, if you take the example of volume, if you take if you go to some shop and ask for milk, you will ask as 1 liter or 2 liter or half liter. That you way you ask. See, liter is not the SI unit system. Okay. That is standard international unit. Okay. It is used to measure the volume. Okay, just it is used to measure, it is not the SI unit, that you have to remember. See, it is, if you take dm cube, okay, that is 1 liter is equal to 1000 ml, but 1000 centimeter cube is equal to 1 dm cube. Okay, see, you can see here only it is deci. You can observe all the symbols here, it is small d, so you can say as d is deci. M also is given here, you can see it is milli, so deci milli cube. Okay, you can read as that. And if you have to find density, it is the amount of mass per unit substance volume. Okay, you can read the definition of density as, it is nothing but the substance. Okay, density of substance is nothing but amount of mass per unit volume. How much it is amount present per mass unit volume, it is nothing but the density. And SI unit system is kg per meter cube, or see, this they have written as kg divided by meter cube, right? This, if you write this as up here, it is kg, you keep as it is. If you have to take the denominator to numerator, what we do, it is m power minus 3, you add minus, right? If it becomes reciprocal, it will be reciprocated, and it is kg per meter cube. And this has very quite large, and chemist often expresses density in gram per centimeter cube. Most of them do in gram, or kilogram is also SI unit. Okay. And if you have to find out Temperature is nothing but you have to find out the measured temperature. What is the temperature at particular place or something like that. See, you measure also in degree Celsius, that is this, and Fahrenheit, degree Fahrenheit, and Kelvin also. Kelvin is the SI unit. Okay, you should remember this one formula which is very important. See, degree Fahrenheit is equal to 9 by 5 into degree Celsius plus 32. That is, you have to remember this when you are converting the Fahrenheit to Celsius, or if it is Celsius given also, you can find Fahrenheit. Okay, and if you have to relation between Kelvin and degree Celsius, Kelvin is equal to degree Celsius plus 273.15. This is plus 32, this is 273.15. Note, below zero temperature, that is negative values, are possible in Celsius state, but in Kelvin state negative temperature is not possible. See, when you say as minus 4 degrees Celsius, if you go to some snow city or snow park, something like that, you say as it was minus 4, it was too cold, like that, but you measure that in degree Celsius but not in Kelvin. Next concept, if you come, is scientific notation. It is one of the most important question for board exam also. See, it is nothing but the number in which any number can be represented in the form of n into 10 power n. Okay, here it is small n, here it is capital N. Let's see what are those small n and capital N. Where small n, this is exponent is there, no? What that represent is an exponent having positive or negative values. It can have either positive or negative values. And n, this is there, no? It can vary from 1 to 10, that is 1 to 10. Okay, this is, it can be either positive or negative value. This can vary from values from 1 to 10. And see, if you have to find the scientific notation, we'll solve for one example they have given. 232.508, as you have to write as, see, if you shift 2 points, see, here you are shifting to left side. Okay, you are writing as 2 point, you shifted 2 decimal point, right? 2 point, see, it is, first we will write what they have given. 232.508 is the value they have given, right? See, let's do the changes in different colors so that you can understand. See, you're shifting this point till here, that means 2 point is shifted, this is not present now, so it becomes 2.32508. that means how many values you changed is 2 values, right? That into 10 power 2 you have to multiply, because you change the value from here till decimal value from here till here, right? So that is same way. If you are shifting to left, that is, you have to remember. Okay, you can easily remember as, if it is left means it is, you have to add as positive. Okay, L means positive. Next, R means you have to add negative values, negative. Okay, see, let's see another example they have given is 0.1 2 3 zeros. Okay, 1 2 and 3 zeros, and 1 6 is the value they have given. Let's do the change. See, here it became 0 point something values, and you can change this in very easy form. See, you have to shift as, you can shift as 1.6 or 16 as you wish, but here I am shifting it here after 1. Okay, so it became 1.6. and how many value decimal values you are shifting? Here is 1, here is 2, here is 3, and here you are shifting, right? So 4, you have to multiply as 10 power minus 4. This you did right rotation, that is right shifting, so you have multiplied as minus 4. If it was left shifting means it was plus. Okay, this you have to remember. You can shift here also, it will become as 16 into 10 power minus 5. You can shift, but you have to see the values, how much decimal you have shifted. That's it. Next comes is precision. Precision refers to the closeness of various measurements for the same quantity. It is nothing but the various measurements, how much like how much close it is, some if you take some two quantities or some same quantity, if you take also, what are the closeness of their both answer for measurements? That is nothing but precision. Accuracy is the agreement of particular value, the overall total value you will get, right? That how much perfect it is, to find that we will use as accuracy. Next very important concept is this scientific notation is also very important. It will come in future, all the numerical problems and all. See, next comes is significant figures. They are the reliability of a measurement is indicated by the number of digits. What it is, number of digits used to represent it. To express it more accurately, we express it with digits that are known. These are called as scientific figures. From here till here is the definition, you have to read it. Okay, it is very important. They contain all the certain digits plus one doubtful digit in a number. See, what to they said that we have to find scientific figures. Now to significant figures. To find out the significant figures, what are the rules to follow to find out? Let's see on. That means first rule is all non-zero digits are significant. Something like 0 should not be there. Anything than 0 can be significant. Okay, that is the first rule they are saying. Here, see, 6.9 they have given has two significant figures. Okay, that is 6 is 1 and 2, 9 is 2. And while 2.16 has three significant figures, right? 2 is 1, 6, 1, 2 and 3. Okay, that is having three significant figures. The decimal place does not determine the number of significant figures. See, this is point. No, if you consider this, it will be 1, 2, 3 and 4 is 6. Okay, so the decimal value or decimal point is not determining the significant figures, how much number it is there, so that you know need not count it. And next, if you come the as that we know, no, yeah. Now next is a 0 becomes significant in case if it comes between two non-zeros numbers. Okay, if it comes between non-zero numbers means it becomes significant. Here we said no, all non-zero are significant. That means 0 is insignificant. That is the meaning indirectly. Okay, so now we will see when the 0 is significant. See, if it is there a number they have given as 2.03, like you consider or the 0, or you can put here 1 0 here, something like that, but there are 1 and 2 non-zero numbers, right? The 0 is present between them, so it becomes significant. I hope you are understanding this chapter. It is very fundamental concepts for all the rest of the chapters. They have four significant figures, 1, 2, 3 and 4. See, this also comes between 4 and 2. See, 0 is significant. They have 1, 2 and 3, three significant figures. 0 at the beginnings are not significant. See, 0 point something, that is not significant. Okay, they 0.00, that is not significant. Only it has two significant figures. This has only one because only the two number is present here, so it is only significant. Next, if you come to the next rule, all zeros placed to a right of a number are significant. That means, see, there are two non-zero number as 16.0 is the example given here, right? See, this 0 is present after some non-zero number and it is present in right side, so they are saying as it is significant. And if you count the number of significant figures means it will be 4, 1, 2, 3 and 4. See, here only they have given zeros at the end of a number without decimal. See, they are not having point here, something like that. Okay, so they are significant. To count for significant how many numbers are there, we are seeing these rules. Okay, in exponential notations, that means exponential is nothing but power. Okay, the numerical portion represents the number of significant figures. For example, 0.00045 is expressed as, see, we saw now in scientific notation, you shifted 1, 2, 3 and 4. Here you shifted, so you write as 4.5 into, because you shifted right. See, here only you can see rules I have written. If you write as right, you have to mark it as negative. So it is negative. Okay, 4.5 into 10 power minus 4 in terms of scientific notations. Okay, and the next comes is The scientific notation significant figures in this number is 2. Okay, see 4 and 5. Okay, that is 2. While in Avogadro number, see 6.023. This is very important term you have to remember. That is Avogadro number. That is 6.023 into 10 raised to plus 23. This is one term or one numerical you can think as it is one law. We will see the laws which will upcome, and you have to just remember this as 6.023 into 10 raised to 23 is the Avogadro number. It is 4. See 1, 2, 3 and 4 is there. So it is 4. The decimal does not count for significant figures, right? For example, 3, 4, 5, 6, 0, 1 has 6 significant figure. 1, 2, 3, 4, 5 and 6. They have but can be written as 345.601 or 0.345. That can be written, or it can be has 3 point something. All have same number of significant figures. That is the meaning they are saying in rules. I hope you got the rules. Next comes is retention of significant figures or rounding off. How you will round off the significant figure? If it is all, these are very basic concepts that you need to understand very carefully. If the number is something as 5.5, you will round it off to next number, that is 6. If it is 5.4 or 5.3 or 5.2 or 5.1, you will round it off to 5. It is, if it is greater than this, you will round it off to 6, as I said. Okay, now let's understand this example I gave so that you can easily understand. Next, see the rules they are saying. If the digit coming after the desired number happens to be more than 5, that means greater than 5 they are saying. That means that have to be rounded off to, see 317. 7 is there, right? 7 is greater than 5. So round it off to next number of this previous element. Previous element is 1. So you write as next number, that is 4.32. Don't get confused that you have to write as 4.4. You have the next number of 3 is 4. Don't get confused. You are rounding off the last element, right? Last number, that is, it is 7. So if you have to understand this, it is greater than 5. If it is greater than 5, you have to round off the previous element. You can see it is 1. So you write as 4.3 as it is, and the next element of 1 is 2. You write as 4.32. I hope you are getting this. Next is the digit involved is less than 5, means you have to write the previous element, that is preceding. Okay, this is succeeding. Next 3-1 will change to 3-1 as it is. Okay, see 2 is there. See, you can understand why they kept the same. You have to make it as 4.30. No, you have to not change it to whole previous digit. Just you have to see that it is less than 5, right? So you have to keep it as it is. 4.31 is the rounding of the number. If it is happened to be 5, that should be also done to next number. See, it is 5. So 7. 7 is next number is 8.38. 5 is equal. So you have to make it as 36. Okay. The same value we have to round it off to 7. It should be 7 here. Okay. And next, the dimensional analysis. During calculations, generally there is need to convert units from one unit system to another unit. That means you have to, in some question they will be given in centimeter and they'll ask the answer in meter. When you have to convert this centimeter to meter, you have to multiply, or you have to divide, or you have to add something, or you have to do some operations, basic BODMAS operations or some operations. So you need to understand this dimensional analysis. That is the definition they are going to say here. See, they have given us 5 feet and 2 inches height of an Indian female is converted to SI unit. See, height they are saying, right? Height should be in what? Meter. They have given in what? Feet and inches. So you need to convert it into meter, right? So what you have to do is, see, they have given as 5 feet and 2 inches. 5 feet and 2 inches, right? They have given. See, you have to know what is the basic need you have to convert. That means 1 inch is equal to 2.54 into 10 raised to minus 2 meter. See, they have said as meter. So if you have to convert it into meter, you should know the relation between inch and meter. The relation is 2.54 into 10 power minus 2. That is the relation. See how they are doing this problem. They have kept the 5 feet and 2 inches as it is. That means 5 feet. Okay, 5 feet, the value of 5 feet became 60. Why? Because 1 feet is equal to how many inches? 1 feet is equal to 12 inches. This you have to remember. Okay, this is very important. I have not mentioned here anywhere. This you have to remember. This is feet to inches. Okay, 1 feet and is equal to 12 inches they have given. See, 5 feet. 5 feet means 5 feet is equal to 12 into 5 inches, right? So you have to multiply here 5 and here 5. It became 5. 12, 5 2s are 10. 1 carry you will go. 5 1s are 5 and 1 is 6. 60 inches is the answer. Plus 2 inches they have given, right? So plus 2 inches you have to do. That means you will get a 62 inch. See, for 62 inch, if 1 inch is this much, if you have to calculate for 62, that means you have to multiply by 62. As simple. Okay. 62 into 2.54 minus 2 power meter divided by 1 inch, because you have this as 62 inch. That means you have to, like, for 1 inch it is that much. For 1 inch it is this much, means for meter it will be 1 inch this divided by this, right? So you have to multiply, and that you will get the answer as 1.58 meter if you calculate this, multiply. And next concept is physical classification of matter. What is the physical classification of the matter? Let's see on one by one. Volume, this we studied already. It is definite. See, what are the states of matter? We know it is solid, liquid and gas. What are the possible properties of them, and what is the state of them in solid? Volume means you can take some milk or something like that. It is definite and definite. In gas it cannot be, so it is saying as indefinite. You can see all these table as I have given. Next is chemical classification of matter. This was physical. Okay, physical classification. If you come to chemical, they'll be having two parts, that is mixtures and pure substances. Mixtures are nothing but homogeneous and heterogeneous, and pure substance is nothing but elements and compounds. Homogeneous, heterogeneous, as you all know from school we are studying. First they are saying about elements. Let's see on one by one. Elements are nothing but they are the simplest form of matter that cannot be split into simpler substances or built from a ordinary chemical or physical method. See, if you take carbon is an element, right? If you take the carbon and if you say as I can split carbon, no, it is not possible. And if you say as it is arrived from some chemical or physical method, no, it is one of the most ordinary, or it is not ordinary, it came from not simpler method. They have invented some elements. One scientists have invented so many elements. It can be various things, but we cannot say as it is ordinary thing that we can invent or something like that. It is not so easy. So that is called as elements. And next, elements are classified as metals and non-metals. See, metals, metals, non-metals and metalloids, that we will discuss later. Compound is nothing but a pure substance made of two or more elements. See, it is arrived from elements. That means made up of two or more elements combined. That means in definite proportion, means same proportion of mass, which could be split by chemical methods. That is the compounds. Characteristics means it will have definite proportion. They are totally different from elements, and they are homogeneous, means homo means same type of division they'll be having among themselves, or composition, we can say. And next, they are classified as inorganic and organic compounds. Inorganic are those that have non-living, and these are nothing but living. Organic itself suggests it is living. Okay. Next comes is mixtures. It is combination of two or more elements, compounds in any proportion, so that they do not lose their identity. Mixture do not lose their identity. Air is the example of mixture. Mixtures are two type, homogeneous and heterogeneous. As we know, homogeneous is same composition throughout the sample. See, that means air, seawater, gasoline or brass, something you can take example, they will not change, they have the same composition throughout. Air is nothing but it is having same. See, next heterogeneous is nothing but they are having different composition, that is different composition. They have the separation between constituency and can be seen with our eyes. Salt and sand, if you mix that both, it is visible that this is sand and that is salt, so that is called as different compositions, right? So that is heterogeneous. Chalk powder in water, if you mix chalk powder in water, you can observe water and white powder will be visible, that is chalk powder, that is visible with our eyes, that is heterogeneous. Next is, see, we were studying about Avogadro law, the number I said, that is 6.023 into 10 to the power of 23, that all comes here. You can see that law of conservation of mass, it states that matter or mass, okay, can neither be created nor be destroyed. The mass, that's this we are reading from since so many years. This says that the matter that we are seeing, that can be neither created nor be destroyed, which is there, that cannot be destroyed also, which is not there, that cannot be created also. That is the law they are saying in law of conservation of mass, that was invented by or given by Antoine Lavoisier, okay, in 1789. Law of definite proportion, or it is also called as law of constant composition. That means it was proposed by Louis Proust in 1799. This was in 1789. A chemical compound always consists of same elements combined together in same ratio, irrespective of method of preparation, of source or where from it is taken. See, if you have to prepare a chemical compound, that is compounds we studied, no, it is mixture or two or more elements is combined to form a compound. So compound always consists of same elements combined together. See, there only we studied in compound definition, it is present in same ratio, and irrespective of the method of preparation, how you have prepared, or the method, which method you have taken to prepare those compounds, something that is not need not be worried about that. So, or the source where it have, or the source means source you can say as something as the material that you have taken, from where it is taken, that is nothing, it is not irrespective of that, means they are same, taken in same ratio, no, to combine. So irrespective of what the method you are using, or what are the elements you are taking, or what are the material you are taking to do, that is doesn't matter. Next comes is law of multiple proportion. The name itself suggests multiple proportion. It was presented by Dalton in 1803. It states that when two elements combine to form two or more compounds, then the different masses of one element will combine with the fixed mass of the other, bear a simple ratio to one another. See, it states that when two elements combine to form a two or more compounds. See, some two elements combined as to form a two or more compounds. Then the different masses of one element. See, there were two elements, right? The different masses will be there of one element. That will combine. This is one element and this is element, means they will combine with a fixed mass of each other, okay? And bear a simple ratio to one another. They'll be having some ratio and they'll bear it. That is called as multiple proportion law. Next comes is Gay-Lussac's law, or it is called as of gaseous volume, means that is used to describe the volume of the gas. See, it was given by Gay-Lussac and in 1808. According to this law, when gases combine or are produced in a chemical reaction, they do in a simple ratio by volume, provided all gases are at same temperature and pressure. See, or this is very important in this law, they are having same temperature and pressure. See, if you take some chemical reaction, that is H2 plus Cl2 gives 2HCl. This you have to learn to balance the equation. See, here they have given us H2 and they have given us Cl2. Cl2 means, as you all know, it is chlorine. H means it is hydrogen. It became 2HCl because see, here it is 2, here it is 2. So if you write 2 here, it will be for 2 hydrogen and 2 chlorine, right? So it is balanced. That you have to see the left hand side and right hand side also. Next, this is also gaseous, this is also gaseous, and this is also gaseous. We got the product. All are in same ratio, that is 1 is to 1 is to 2. Okay, 1 is to 1 is to, see, 1 is to 1 is to 2 is the ratio. Okay, Avogadro law that I said, no, that came 1811 was discovered by Avogadro, is the name of the scientist. According to this law, volume of gases at same temperature and pressure should contain equal number of molecules, is the mass law given by Avogadro, and the number that is represented as 6.023 into 10 to the power of 23. Dalton's atomic theory is nothing but made up of tiny indivisible particles called atoms. They are having identical shape, size, mass, and other properties. They are different in all the perspectives, and they are smallest, and they are having whole number ratios. They are called as molecules that cannot be created, divided, or destroyed. As we studied, no, it cannot be created nor be destroyed. That they are saying. See, next comes is atoms and molecules. Atoms and molecules are nothing but they are the smallest particle that may be having not independent existence in an atom. They are the smallest particle, okay, is called an atom. Smallest particle is called as atom. It is having independent existence is called as molecule. Okay, next they are divided as homoatomic and heteroatomic. Homoatomic means having same element, and hetero means it is having different elements, and they have different atomicity also. Monoatomic, diatomic, triatomic, polyatomic. They are having one element or one atomicity value or number of elements that atoms you take. One atom having two atom, three atom. Poly means it is having containing more than 3 atoms. They are called as polyatomic. Next is atomic mass unit. Atomic mass unit. They are defined as a mass exactly equal to 1/12th. 1/12th the mass of the carbon 12 atom. That means, see, 1/12th of carbon 12 atom. Okay, the value, if you do this, you will get the answer as 1.66 into 10 to the power of minus 24 atomic mass unit. Okay, it is replaced by U, which is known as unified mass. If you write unified mass is also correct. If you write atomic mass unit is also perfect. And if you take atomic mass, it is the average of relative mass. Okay, see, mass of an atom, what it is there, divided by 1/12th of mass of carbon 12 atom. Okay, that is that. And gram means it is having, see, if you take the example as it has 6 AMU. AMU is nothing but atomic mass unit. Therefore the gram will be also 16. Okay, the oxygen value is 16, right? Atomic mass, you should remember atomic mass and molecular mass. It is very important to do the numericals, so you need to follow that. Next is you have to find as molecular mass. It is defined as average relative mass as compared to the mass of carbon 12 taken as 12. Okay, here it is not 1/12, here it is 12. If you take the molecular mass of oxygen, it is 32. Atomic mass was 16, molecular mass is 32. Formula mass, see, you can study mole concept is divided as amount of which contain the same number of chemical units, and the for exactly 12 for pure carbon 12, and Avogadro number is this. Okay, next you can study this molar. These all are definitions. Now comes this empirical formula and molecular formula. This is very important concept, and there is short question in this concept. percentage composition. It is nothing but percentage if you are finding of the element, that means the how many mass of element is present in one molecule of the compound divided by molecular mass of the compound into 100. Why? Because you are finding out percentage. Okay, that is why you are using percentage into 100. Okay, now if you see divided by that, if you have to find out empirical formula and molecular formula, the relation you need to know. That means molecular formula is n times of empirical formula. If you denote as mf is equal to n into ef. Okay, if you want n you bring here means mf will be as it is, as we are having ef here, it will go to denominator. Okay, this is the relation you need to know. It is very important concept, and there is a short question from this concept. Chemical equation means shorthand representation of a it is changed in terms of symbols, formulae, substances. It is known as chemical equation. And a limiting reagent is nothing but the agent gets consumed, like it is a reactant that you use to consume that, to limit the amount of product formed, or to limit means you should have finite number, it can be going till end, so you have to limit it. Okay, reactions in solution means mass percent, volume percent, and molarity is important. Mass percent means it is mass of solute divided by mass of solution. Okay, solute means it is present in very less quantity, that you remember. Okay, solute and solvent. Okay, there are two concepts, right? Solute and solvent. Here also volume of solute by volume of solution into 100 because you are finding mass percent. Molarity is nothing but number of moles of solute dissolved in per liter solution, that is denoted by capital M, and it is number of solute divided by volume of solution in liter, N by V. N is nothing but N number of volume V. Okay, next is molarity, that is mass moles of solute, that, and there was number of moles. Okay, you have to look into it. Here is number of moles, but here it is moles, and it is weight, so into 1000. Okay, you are finding for 1 kg. Here it is not percentage. Okay, next mole fraction is nothing but it is the ratio of moles of one component to the total number of moles present in one solution. It is expressed as x. Okay, small x, mole fraction. And if you come to the formula, moles of the solute divided by moles of solute plus solvent. Okay, moles of solute you should take in numerator, you should do the sum of solute and solvent, that is mole fraction of solute. If you want for solvent, you should do the same. Here it is solvent, here it is solute plus solvent. Here the mole fraction and of solute and solvent will be always equal to 1. If you take any example, for you can take as see, let's do one example here only. You can take for solute is as 2, and divided by solute you have took as 2, and this you take it as 3, and you take it as 4. Okay, 4, and you will get by divided by uh, 2 plus 4, that is 2 divided by 6, 1 by 3. Okay, 1 by 3, if you add 1 by 3 plus what is mole fraction of solute. Okay, you found out for solute, that is 1 by 3. Okay, 1 by 3 is the found out for solute, 1 by 3, remember. Okay, for solvent, if you are finding, you took as 4 divided by 2 plus 4, right? You took as 4 divided by 6, that means 2 no 3, it is here 2 plus 2 by 3. See, here you can see LCM is 3, that is 1 plus 2. 1 plus 2 is nothing but 3 by 3, that means it is 1. See, the verification of this step I showed, that said, by taking a numerical. Mole fraction of solute, here you found out as solvent. Okay, here was solute. And this is how we study this chapter. If you have any let me know if you have any queries in the comment box, and for next videos, after all the videos, I'll make sure to do all these questions which I have prepared also with the numericals having it. And thank you for watching the full video. Please make sure to like, share, comment and subscribe to my YouTube channel. Next chapter will be coming soon. Stay tuned and share with your friends also. And you can DM me on Instagram. You can also get this PDF. You can DM on Sporify, SPORIFII_Learn is my account, and you can DM me. Thank you for watching. Stay tuned.